Hi everyone, today we'll be working on a few questions that go along with what you learned from the video yesterday. I'm going to go through and do some of these questions with you, and then you'll work on the other ones and submit those. So for this first one, the directions say to find the equation of the secant line on the given interval. If we look at number 1 here, remember from yesterday that to find the equation of the secant line, we know that the slope of this line, or the average rate of change, is the same as the slope of the secant line. So I'm going to start by finding the slope of this function at -2 and 2. So first I'm going to find v of -2. Which will give me -8 plus 2, which equals -6. Then I'm going to have to find v of 2. Which is going to give me 8 minus 2, which equals +6. Now that I have x and y values, I can go ahead and find the average rate of change. So -6 minus 6 over -2 minus 2 will give me -12 over -4, which equals 3. This is the average rate of change between these 2 points, which is also the slope of the secant line. So if we go back and read up here, we want to actually find the equation of the secant line in slope-intercept form. So remember slope-intercept form from earlier this year is y equals mx plus b. We also learned point-slope form, which is y minus y1 equals m times x minus x1. So right now, instead of solving for the y-intercept, it might be easier for us to use this point-slope form and then just change our equation to go back into slope-intercept form. So following this equation I have in green, I'm going to have y minus, if I choose one of these y values like -6, so y minus -6 will give me y plus 6, equals, we said m is equal to 3. And then x minus the x value here for -6 was -2, so minus -2 will give me +2. I can simplify this a little and get y plus 6 equals 3x plus 6. And now if I want to change this to slope-intercept form, I could just subtract that 6 over and get y equals 3x. Okay, so that's the first problem. So for all of these, first you need to solve to get some corresponding y values, then find the slope. And the slope of the line, or the average rate of change, is the same as the slope of the secant line. And then you just have to do one more step like I have in green to get the rest of your equation. So I'm just going to go down here to number 4 and set up one of these for everyone. So the directions here say to use the interval from x, x plus h, and find the expression that represents the slope of the secant line. So this was in the video yesterday, which looks like the difference quotient, if you remember the difference quotient from earlier this year. I'm just going to find the slope using this interval. So I'm going to have slope equals f of x plus h minus f of x over x plus h minus x. Okay, so my next step would be to go into the function, and I'm going to find f of x plus h is going to be x plus h squared minus x plus h, then minus f of x, so minus x squared minus x, and I can simplify this denominator. So x plus h minus x is just going to give me h. Okay, now we need to take a second to multiply out the top, and I'll get x squared plus 2xh plus h squared. Then distributing that negative, so I'll have minus x minus h minus x squared plus x, and again, all of that is over h. Okay, and then we can look to simplify our numerator. So this x squared and this x squared will cancel out. This x and this x will cancel out. So we're left with 2xh plus h squared minus h all over h. And we could simplify that further by taking out h as a greatest common factor on the top. So h times 2x plus h minus 1 all over h. These two h's will cancel out. So we're left with the slope is equal to 2x plus h minus 1. Okay, so you guys can follow that same idea to finish up 5, 6, and 7 as well.